3-2 solving system equations by graphing, and 3-4 solving system equations using 3 variables. So let's get through this worksheet. So solve each system equations by graphing. So we're just gonna graph each one. X is less than 3. Here's my x, here's my y. So all I ever do is follow the tally mark. So 1, 2, 3. It is an open circle because there's no line beneath it. So it's a tally mark like that. And then less than, let's make this lighter. Right, so less than is to the left of it. Numbers are less than 3, so on this side. So that's where we'll be shading. Okay, y is greater than -4. So again, follow the tally marks. On the y, here's my y. So 1, 2, 3, 4. This one is equal to, so it's going to solve line. And then for shading, we're going to shade above greater than, numbers greater than -4, so all this. Like that. Then your answer is where they're both shaded. So for us, that'll be this part. So there you go. Same thing with the next one. Y is greater than 0. So again, here's my y. Just follow tally marks. 1, 2, -1, 2, 0 is right here. And it is equal to, so solid line. And we're shading above. Okay. Y is less than x. So there's a trick to do that one. Y is less than x. The trick is add a +0. Okay, now it's a slope-intercept form. So my y-intercept is at 0. And my slope is 1/1. That's how we do these. The easiest way to do that one. Just add a +0 and then it all makes sense. So 1/1. It's a dotted line. And it's less than. So remember, less than means below. I'm below this dotted line. So if I'm going to shade in green, we're below that line. So we're like right here, all this. Then our answers, where they both shade. So it's that little spot right there. So like that. Next one. So we'll solve for, so in this one, we got to solve for y so we could graph it. So we'll do 2x over, so 3y is greater than -2x plus 6. Divide by 3. So y is greater than -2x over 3 plus 2. So we're going to graph that, plus 2. So we'll -2 over 3. And it is a solid line. Like that-ish. And it is greater than, so we're going to shade above. Next graph, absolute value. So then we're going to have to do absolute value. Moving to the right 6. Inside opposite, so right 6. And then it's a parabola. It's a, sorry, absolute value to v. And it is solid also. Whew, thought I messed that up. Like that, just a sketch. And less than below it. So we're going to be below that. So it'll be all this. And then again, oh, I guess also technically all the way down here. I was just doing the solution. The solution, though, would be this part I did at the beginning. It'd just be all this part. Right? Above this line and below this line. And if you want, you don't have to draw both of them. Most of the time when I do this, I just draw the solution. So there we go. That's how you graph. That's how you solve by graphing. Just graph both, shade, and do your thing. Okay, now let's talk about how to solve a system equation with 3 equations. I mean, let's do it. I talked about in the video. So I like to label these A, B, C. And the biggest trick is eliminate the same variable twice. The same variable twice. So we're going to limit the same variable twice. So you just pick a variable, eliminate. You generally want something that's by itself. So it could be x, it could be the y's, it could be the z's. It doesn't matter. I think most people are more comfortable doing x. I'll do x. So we're going to eliminate x twice. So let's do first a and b. You'll do a pair of things. So we're going to do a and b. Right, and if I want the x's cancel here, I'm going to multiply the top row a by -2. So that these x's cancel out. So multiply a by -2. So it's going to be like this. Remember, very easy to make a small mistake here. We're going to multiply everything by -2. So it's going to be -2x plus 4y minus 6z equals -14. Right, we multiply the whole row, even the 7, by -2. Make sure you multiply all correctly, because it's easy to make, like, forget a negative or something like that. B, I'm leaving it the way it is, so I'm not going to touch B at all. 2 plus y plus z equals 4. I'm going to add these up. X's cancel out like they're supposed to. I get 5y minus 5z equals -10. So I guess I get that. I just add them out of like terms. By the way, if you notice here, I could divide all this by 5 and make my life a little easier. So I get y minus z equals -2. Right, just to make it a little easier for myself. That's one of my new equations. Now we gotta do it again. I gotta use a different combination. So I could do B and C, or I could do A and C. And to me, A and C is easy also. I'm gonna do A and C because I just multiply A by 3, and it'll cancel out with C. If I did B and C, I gotta multiply this by, like, I gotta find a combination. So over here, I'm gonna do 3 times A, and I'm gonna do C. And multiply top row by A by 3, so I'm gonna get 3x minus 6y plus 9z equals 21. And the bottom row, the second one, C, I'm gonna keep it the way it is. 3x plus 2y minus 2z equals -10. Add them up, cancel, -4y plus 7z equals 11. So I have that equation. So now you notice I have 2 equations. Hopefully I had them all correctly. It looks like I did it all. I have 2 equations with the exact same variable. This is why you eliminate the same variable twice, because these match now. I can just do this like a normal problem. So now I have y minus z equals -2 and -4y plus 7z equals 11. So elimination. I multiply this top row by 4. So I get 4y minus 4z equals -8. If I add these up, these cancel. I get 3z equals -3. Positive 3 actually. Right, that's 3 and that's also positive 3. Divide by 3. Z equals 1. So once you get your first variable, that's the hardest part. Now we just work our way back up, right? I have z equals 1. I gotta find out the other 2. Well, plug it into one of these equations. Just work your way back up. I'll plug into this one. Looks like the easiest. Y minus 1 equals -2. So add the 1 on both sides. Y equals -1. So now I have y and z. I gotta find x. So to find x, you go back to one of the original equations. Right? It doesn't matter which one. I'll actually use the middle one. I think that's probably the easiest. So 2x plus y, which is -1, plus z, which was 1. Too far up. There we go. Equals 4. These cancel out. I get 2x equals 4. Divide by 2. X equals 2. So I have x equals 2. I have y equals -1, z equals 1. So 2, -1, 1. That's my answer. So that's the process, right? Just eliminate the same variable twice. So in this case, I eliminated x twice, and I got my 2 new equations. On one of them, I divided by 5 to make it a little easier for myself. But once you get your 2 new equations, just like the first lesson, solve by elimination or substitution. I did that, and I got 1 and -1. And once you do that, plug it into one of the original ones, and then you got all your answers. So let's do it again. This one's a little annoying because it has A, B, and C. It has my ABC. So 1, 2, 3. I'll do Roman numerals. So now here's the trick with this one. Look at the middle term. It's missing B already. So you can use that to your advantage. Like I always said, it moves on to the finals. It's one of my new equations. So to me, one of my new equations I already have, right? Like when I got to the final 2, that's in there already. The key though, if I did that, that means we have to eliminate B. Right, so now when I do A and I do row and I do 1 and 3, sorry. I'm used to it being like ABC. When I do equation 1 and equation 3, I gotta get rid of B again because I needed to match this guy. So you don't just eliminate anything. You have to eliminate the same one. Again, you could do that. You don't have to do it. You could do it like the normal way if you wanted to. Getting rid of the A's is fine. Then get rid of the A's up here. Like anything works. But if you want to use that to your advantage, you go, okay, B's gone. I'm going to use that. Then for 1 and 3, I gotta get rid of b again. So it matches. If I want to get rid of b, I'm going to multiply the top row by 3. That way that becomes -6 and they cancel out. So I'm going to get 3a minus 6b plus 3c equals -6. Over here I'm just going to leave this alone. Add down, I get 2a cancels plus 7c equals -3. And again, I can plug that over here. So now I have my next step. I just got to solve these two like normal. And once I solve these two like normal, I'll get a and c. And I can plug it into any one of these to find my b. So if I want to cancel out, if I want to solve here, I'll multiply the top row by -2. So I get -2a minus 10c equals 24. That way a's cancel out. I get -3c equals 21 divided by -3. C equals -7. So I have C equals -7. Don't forget, I do gotta find my A, so I gotta plug it back into one of these to find my A. I think this one's easier. Alright, this one right here. So A plus 5 times -7 equals -12. A minus 35 equals -12. A equals 23. 23. That seems off. I might have messed up somewhere. C equals -7, right? -3. This looks all good. I'm just double checking my work because it seems a little funky, but it looks all good. That's right. That's right. That's -7. -35. Yeah, it looks all good. Just a little funky. So I have A and C. Now you plug back into any one you want to find your B. I'll plug it into this one. 1. So 23 minus 2b plus -7 equals -6. Oh, we're running out of space here. Add like terms. 23 minus 7 is 16 minus 2b equals -6. Minus 16 minus 16. -2b equals -22. Divided by -2. B equals 11. Well, at least none of them are decimals. So we get that. So does it work? Next one. So we're solving by elimination. We're solving by graphing again. So we're just going to do each one by one, right? So x is less than 4. Again, here's my x. You go to 4, follow the tally mark you would make, and it's solid. I cannot draw a straight line apparently. And then less than, so it's over here. Okay. Y is greater than -3x plus 12. So we're doing that one now. So plus 12, it's off the grid, sorry. Down 3/1. And then this one is dotted. And we'd be greater than that guy. Okay, so greater than that guy. Man, it's off the grid, because greater than that guy's over here. And then the last one, y is less than 9. So 9 is right here. And it's solid. And we're less than that. So, not my best graph ever. You're above this line. You're to the left of that line. You're below this line. So, really, it's just this little spot right here. Again, if I do a nicer graph, it'd be a little bit bigger. But it's just that triangle right there. That's our answer. Okay, last one. Chelsea has final exams in calculus, physics, and history. She has up to 25 hours to study for the exams. She plans to study for history for 2 hours. She needs to spend at least 7 hours studying for calculus. But over 14 is too much. So, let's talk about this one. She hopes to spend between 8 and 12 hours on physics, write a graph system representing inequalities. So it's a little messed up here. 25 hours of study, but really, 2 of them are history. So you actually only have 23 hours to study. It's not 25. She wants to spend at least 7 hours on calculus, but over 14 is too much. So she's trying to say she wants to spend for calculus. She wants to spend between, let's make calculus x. She wants to spend between 7 and 14. That's what it's saying. And let's say, what's physics, right? So physics, let's say that's y. She wants to spend between 8 and 12. So like that. And then we still need one more thing. We need a total. So we need like a total equation, which is if I add calculus plus physics, what's your max? Sorry, physics is y. What's your max time? Well, again, it said 25, but really two of them for history, so it's really only 23. So she has to be less than or equal to 23. 23 is the max she could spend. So here are equations. We got to graph this. So don't forget this is x, this is y. Now these might look scary, but these are the easiest things to graph. So 7. So if you want to treat it like this, it's x is greater than or equal to 7, and x is less than or equal to 14. But really all I do is this. Do a line at 7. Do a line at 14. And you're between the two. So you're going to be somewhere between these guys. And we're going to do the same thing with physics. Physics between 8 and 12. So do a line at 8. And do a line at 12. You're between those guys. So now we're in this little box here. We have one more thing to do though. We gotta do y plus x plus y equals less than 23. So for that one, solve for y. Y is less than or equal to negative x plus 23. So we're gonna start at 23. I'm gonna go down 1 over 1. Down 1 over 1. Along the slope. That I go off. Try not to go off. It's actually kind of important that I'm on the actual lines. Something to this effect. Right, and then it's less than, so you gotta be less than that line. So if I was in shade, be anything below that line. So our answer is this little box right here. Anything in that box is a proper answer. If they actually, and then write a graph of some inequalities, got this situation. If I ask you for what's one thing she could do, like what's an example, just pick a point there. So like that point there is 9, 10. She could spend 9 hours in calc and 10 hours in physics. Right, just different examples of what she could do to fill her thing. Anyway, that's the video.